Did you know that it's recommended to conduct a measurement to prove that a collaborative robot is safe and correctly implemented for a specific application? To help any robot user, the COVR project developed so-called protocols, which are a step-by-step guide for how to make these measurements. In this video, we are going to look at the protocol Test Robot Arm Does Not Overreach Vertical Planes. The specific purpose of this protocol is to validate the safety skill, limit range of movement, by observation. Its scope can be applied to robotic arms operating indoors in several application domains. Let's consider a situation where a human shares a workspace with a collaborative robot. When installing the robot in a shared workplace, it can be fundamental to properly limit the operating regions. Besides accurate programming, the robot working space limits can be defined by dedicated functions of the safety controller, such as setting up vertical planes, limiting robot movements. But how do you check that the system behaves in compliance with these limits? To ensure the robot range of motion does not overreach the defined vertical plane, we can use the COVR protocol Test Robot Arm Does Not Overreach Vertical Planes. In our case, we will install a laser-based safety sensor that corresponds to the vertical plane in order to ensure that the robot workspace limits are respected. We connect the sensor to the robot controller as illustrated in the user manual, and we take a picture of the final testing setup. At least 3 testing points in the surface of the identified vertical plane must be set. Being, in our case, a virtual plane, we can move the robot towards the light barrier until the red LED on the sensor indicates that the laser detection zone has been reached. You can set the testing points by moving the robot in manual guidance mode, or use its teach pendant to be more accurate. We can now start testing, approaching one of the individual points with a trajectory perpendicular to the plane. In this case, the red LED indicates that the test failed, since the testing plane surface was overcome. As we see, the operator made a mistake in programming the safety settings for the limiting plane. After applying correct safety settings, let's repeat the test. The green LED indicates that this time it was successful. Repeat the same trajectory, increasing the robot velocity. Other approaching modes must also be checked. For example, a rotating approach at different velocities. The whole procedure must then be repeated for each of the 3 points. This was an example of how you can ensure the safety of your collaborative robot with help from COVR. If you wish to learn more, visit www.safearoundrobots.com.